A very good day to my beloved lecturers. My name is Tae Gui Singh from Group 12 and I'll be presenting the introduction part of our PBL project. This project is conducted to analyze sound signal from different ringtones. Signal processing plays an extremely important part in extracting variable detectors information. It is a subfield of electrical engineering that focuses on the study, alteration, and synthesis of signals such as sound, photographs, and scientific measurements. Signal processing methods may be used to improve transmission, storage capacity, and subjective consistency, and also to highlight or identify components of interest in a measured signal. Digital signal processing is the use of digital processing, such as by computer or more specialized digital signal processors, to perform a wide variety of signal processing operation. The digital signal processed in this manner are a sequence of numbers that represent samples of a continuous variable in a domain, such as time, space, or frequency. A ringtone is a telephone sound which indicates an incoming call or text message. No longer simply a tone or an actual noise, today the term is most commonly used to refer to customizable sound used on mobile phones. In this project, we will analyze sound signal from 3 different ringtones. The main purpose of this project is to understand how digital signal processing is achieved and how to analyze signal.
My name is Gan Chian, matrix number A164964. Okay, so now I'm going to explain what is the methodology of conducting this project. Before the audio is converted for analysis, the 3 ringtone samples are downloaded from the website GGetNet and imported to the Audacity. The first ringtone sample is Alien Worker, the Spectra. Second ringtone sample, Bridge OSK Soundscape of Ado, and the last ringtone sample is Alien Worker Feathered. So the next slide I'm showing all the ringtone collected and their wave pattern in the Audacity software. All the ringtone will be exported to the WAV file to make sure that it is readable by the MATLAB software. Okay, so this slide shows the sound wave of the first ringtone sample in Audacity. And this one shows the sound wave of the second ringtone sample in Audacity. And next, this one shows the sound wave of the third ringtone sample in Audacity. Next, I'm going to show the process of fast Fourier transform by using the MATLAB software. To carry out the fast Fourier transform, the software MATLAB was used to analyze, calculate, and plot the graph. So the next slide I will showing the code used for the fast Fourier transform in order to compute the graph of time domain and frequency domain for all the ringtone in the MATLAB. First, we're going to read all the WAV file which has been exported for Audacity as shown in the first 3 lines of code. For the line 4 to line 6, we're going to find the signal duration of that audio by using the line space function. This function is able to create the time vector for our ringtone sample. Then, we set the length of frequency vector and FFT to be 2 power 10, which is 1024. The reason we set the FFT to be 2 power 10 is because all the ringtone sample is around 10 seconds of duration. After that, we're going to find the frequency factor for these 3 samples. Next, we have to determine the fast Fourier transform of sample Y in 1024 points. After we collecting the value of Y, D, and FFT, F, and G, we're going to start to plot the graph of time domain for the first sample as shown in the last part of this code. After plotting the graph of time domain for sample 1, we're going to plot the graph of frequency domain for this sample as shown in the first part of this slide. The second part and last part of this slide is the code to plot the graph of time domain and frequency domain for sample 2. Next, This slide shows the code for graph plotting for sample 3. Next, this slide shows the code to plot the graph of time and frequency domain for the first ringtone sample in one window. Meanwhile, this slide shows the code to plot the graph and frequency domain for ringtone second sample in a window. Next, this one shows the code for the graph plotting for the third sample.
Hello, my name is Tan Zhixuan and I would like to talk about the results. Throughout this project, we get the graphs with first ringtone, second ringtone, and the third ringtone after the fast Fourier transform, which is FFT, from the first ringtone sample, second ringtone sample, and the third ringtone sample. Figures show the final result of the graphs for all the ringtone samples from MATLAB.
The discussion of our project. Regarding to the result of the time domain graph obtained from MATLAB, we can see that the pattern of all three sound sources is quite similar as they are all sound of ringtone. We also can observe from the two main of the domain, which is first is time domain and second is frequency domain. So for the time domain, there is 3 samples of the sound source that we observe. For the first sample, we can see that there is a fall in between the ringtone because the ringtone was released in an interval. Therefore, it records a rise back after a ringtone is playback. We also can see that there is a remaining signal after the ringtone is released as it is a damping. For the second sample, we can see that the note envelope is the shape of the amplitude or the loudness of a ringtone note through its entire duration. The first part, called the attack, is when the note is first peak and be a sharp increase in amplitude from the 0 to the peak, and after the attack, the decay is the period during the amplitude fall from the peak to the main portion of the note called sustain. During the sustain, the note gradually fall until the release, and then when the note is silent or become the inaudible. For the last sample, it is recorded that there is a fall and the rise of the signal in between frequently, while it is not straight decline to the 0 as the ringtone was not fully played. The note of the entire duration is not constantly, and of the end of the ringtone is still sustained until it stop play. So for the overall, we can see from the 3 sample, we can see clearly show that there is a relatively having a very stable signal over the time, and its peak is considerably calm, steady, and eager. Next, I will discuss about the frequency domain. The fast Fourier transform FFT change the vector amplitude of the audio sample become a vector of frequency bin with both magnitude and phase information corresponding to the difference range of the spectrum. And the FFT result show us that the information of the equal space frequency has been from 0 Hz up to the Nyquist frequency, and this frequency is equal to half of the sampling rate. However, the number of useful band is equal to half of the number of samples at the input. So according to the frequency domain graph, we can see that the 3 sample ringtone has almost the same graph pattern to each other. The first ringtone sample detects the normalized amplitude when the frequency is below 15 kHz, and the second one is below 5 kHz, and the third is below 20 kHz. So we can conclude that all the ringtone samples have the greatest number of low frequency of sound due to the ringtone sample has a higher bass. In a nutshell, we should find the other sound sample if we want to get a various frequency domain. This can help us to obtain more accurate and diversity result. Also, we can use keylab to reduce noise of the sound that exists in the sound source recorded.
In conclusion, we managed to achieve the objective of this project. We have learned a lot throughout the time completing this project. We understand how a software works in digital signal processing. Besides, we also mastered the MATLAB software, which is very useful, and our knowledge towards coding and programming has increased. Audio of different kind of ringtone from different songs are computed using MATLAB coding to undergo fast Fourier transform in order to get the frequency domain graph. Last but not least, we also learned how to work as a team and tolerate among each other. We help each other when any of us encounter any problem. We successfully completed this project within the time given, and this clearly shows that we manage our time well and are able to work as a team. That's all from us. Thank you.